All right, thanks for stopping by and checking out this video. So today we're going to try to figure out how to measure the volume of an irregular solid like this rock. It has a weird shape. How do I figure out how much space an object like this takes up? So the first question I have for you is, here we have a beaker completely filled to the brim with water. My question is, what will happen if I drop this rock into the glass of water? All right, let's find out. You knew that was going to happen because the water level rises. Just like when you get in a bathtub, the water level will rise. We're going to use that to help us figure out the volume of an irregular solid in a graduated cylinder. So here's a graduated cylinder that I've already measured. It has exactly 50 milliliters of water from the bottom of the meniscus. And the question I'm trying to answer is, how much volume does this rock take up? So I know when I drop the rock into the liquid, the water level is going to rise. So let's do it. It's at 50 right now. No water is going to leave the graduated cylinder. I drop in the object, and the water level just went up. It was at 50, and now it looks like it's closer to 55. So let's take that as our reading and go over to the board and try to figure out how much space does the rock take up. So here's what we know. We know that the water was taking up 50 milliliters of space. We added to the 50 milliliters of water the rock. Over here in this diagram, it shows the old reading was at 50 and the new reading is now 55. So to answer the question of how much space does the rock take up, we do not look anywhere down here. What we really need to focus on is this increase. The water will rise for the amount of space that the rock takes up. So this distance between 50 and 55 represents the amount of space the rock takes up. So my algebra problem is 50 plus the unknown volume of the rock equals 55. So how much space does the rock take up? All right, so let's take a look at a couple sample problems like what you might see on this unit's test. So in the first one here, we always have a water level in a graduated cylinder, and it really doesn't matter what the water level is, but we wouldn't want to make it like that first beaker that's going to overflow when we drop the object in. So we just fill in any amount of water that we know is enough that when we drop in the object like this cylinder, that it won't go over the top. So the first thing I need to do is read the water alone, and this one is reading 19 milliliters. And then when I dropped in the object, the water level rose to right here. So from the bottom of this meniscus, I know that these subgraduates are counting by ones, this reading is 29. So the question is, 19, I didn't add any more water, but I did add the cylinder. 19 plus the cylinder equals 29. How much is the cylinder? We could do this by subtracting. We could subtract 19. We could think about it. We could count up. What we really want to look at here is this distance from where the water was to how much it went up. It went up the amount of space that this is taking up. What we don't want to do is we don't want to look right here. This is not correct. That is wrong, wrong, wrong. Students always want to do that, but that would be something like trying to use a ruler. Now look, the thing is tilted. It's got all this water in here and this water over there. And look, it's starting at 10. It's not even at 0. So trying to read it as 21 is not the correct thing to do. What we have to do to figure out the volume of this object is take the difference between the water level before and the water level after. So what we want to do is find this distance. I could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's one way of getting the correct answer, which is 10 milliliters of space that this is taking up. I could also take the higher reading of the liquid, which was 29, and subtract the lower reading, and that would also get me the correct answer of 10. There's many ways to do it, but I really just want you to think about it to understand. Now let's look at the example with the ring. We started off with this much water in the graduated cylinder, which this is at 64. And when we dropped in the ring, the water level went up to right here, which is 68. So the algebraic way of thinking about it is 64 plus the ring, right? We use letters for variables to represent things. 64 plus the ring equals 68. So how much was the ring? We could just think about it in this one and know that the answer is 4, right? 64 plus 4 is 68. I could also compare and count up the way I did in the first one. So 1, 2, 3, 4 is how much the water level went up when the ring was added. And again, what I don't want to do, that students are always trying to do, is they're trying to look right here. Now, first of all, this ring is like, it's like floating in the middle of the liquid because it's not even at the bottom. It's somewhere between 50 and 60. So attempting to read it right here would be the wrong thing to do, because I've got all this water and all this other stuff in here. I only want to focus on this section up here of how much did the water level rise. That is the amount of space that the ring is taking up. So I could subtract again the higher reading minus the lower reading, 68 minus 64, and the correct answer is 4 milliliters. So there you go.